Hey everybody, you're very welcome to this week's video. This is my purchase from eBay this week. It's a faulty, genuine Dell Vostro 5471 motherboard. This is described as being faulty and it's for parts or not working. So let me show you what it looks like. And this is what the board looks like. So what I'm going to do first is a quick visual inspection. So let's take it onto the screen. So this is what the board looks like when I scan it in. So what I'm going to do is zoom in and just bring you for a quick tour, and we'll see if there's anything that stands out as being wrong. You can slow this down and observe it yourself and see if you can spot anything wrong, and put it down in the comments if you do. And on the other side of the board, okay, there's nothing immediately standing out to me there that looks wrong. Okay, I can't see anything there, so I'm going to see if I can find some means of powering it on. I've found a generic USB-C charger which I've plugged into it. Now I've no means of pressing the power button because I don't have the little power button board. But what I'm going to do first is I'm going to check the voltages on the board, and if they all look okay, I'm going to find some way of triggering this board on. On the schematic, I have found a section that speaks about the USB-C connection. So what I've got here is 5 volt VSB is coming in, and it's coming onto this DPS 1113 IC. So I'm going to find that and I'm going to measure the voltages around that. I've located that DPS 1113 right here. That's this IC. So what I need to see is, do we have 5 volts on the input? As you can see, pin 1 is the input and 1 is here. It's actually written here. So this is pin 1 right here. Any one of these capacitors can be, we can take a measurement there to find out what the input is. So I introduce my multimeter in volts DC, and I place my black probe to ground and then take a measurement on any one of these capacitors, and what I find is it measures 5.10 volts. Now our schematic tells us, if we look over here, out is pin number 17. So pin number 17 is this one right here. So what I need to check next is if we have the correct voltage on the output of this IC. Now the easiest place to measure that is just on the capacitor here. So I place my probe to the capacitor and I find that there is 20.12 volts at this point. Our 20 volts on pin number 17 follows this path and is then referred to as plus USB underscore type C. So let's see where that goes. I found plus USB underscore type C further down the schematic, and as you can see here, our voltage is carried on to 3 parallel inductors, and from there it goes on to PQ7613, which is a MOSFET, and then on to PQ7614, and after that point it's referred to as DC in underscore in. Now I don't see 3 inductors anywhere near that capacitor where I measured the 20.12 volts, so I think that's somewhere else on the board. I'm going to have a search around and see if I can find it. I searched around the board and I found the 3 inductors together. Why don't you pause the video and see if you can spot them for yourself? Okay, I'm going to show you now. Well, where those 3 inductors are right here. So if we zoom in here, and as you can see, we have 3 inductors, 1, 2, 3, and we have 1 MOSFET and what looks like a second MOSFET. So this is where I think that our 20.12 volts comes, but I'm going to just confirm that by taking a voltage measurement here.
And with my digital multimeter, I took a measurement at that inductor, well, where the 3 of them are there, and I found that there was 20.12 volts at this point. So that is certainly where our voltage is going. Now, as we saw in the schematic, after the voltage comes through our 3 inductors, it hits the source pins of our first MOSFET. So when I measure at the source pins of our first MOSFET, that's either pins 1, 2 or 3, I find that there is 20.12 volts. So our voltage is good up to this point. Next, I want to measure the gate voltage on the first MOSFET. So once again, in volts DC mode, I place my probe to pin 4, and what I find is that it measures 0.500. So that's 500 millivolts. And the last check I want to carry out here is to measure the voltage at the drain pin of the first MOSFET. So we've got 20.12 2 volts here. We've got 500 millivolts on the gate. What do we have in the drain? Well, if I press it to the drain, I find that we have 20.12 volts. So it seems that that MOSFET is turning on and it's permitting our 20.12 volts through from our source to our drain. The drain pins of the MOSFETs are connected together, so I'm going to assume the same 20.12 volts at the drain of the second MOSFET. But I do need to measure at the source pin of the second MOSFET, and what I measure there is 20.02 volts. And just to be comprehensive, I took the measurement of the gate of the second MOSFET and I found that the gate of the second MOSFET measured 18.29 volts. So it looks like our main power rail is good. I'm measuring 20.02 volts on our main power rail. However, just from the measurements that I've taken so far, there's one thing that concerns me, and I'm going to show you what that is now. I've zoomed in a bit closer and I've written out all of the values that I'm measuring on the pins of the first 2 input MOSFETs. So this is the situation. We've got our 20.12 volts coming in. Both of our MOSFETs are switched on and we've got 20.02 volts on the main power rail. So what's the problem? Well, my difficulty here is the value of the gate pin on the first MOSFET seems to be pretty low. I've checked this again against other laptops that we've had on the channel that are exactly the same SI7121DN P-channel MOSFET, and I've measured values of like 6 volts, 3 volts, very stable voltages on the gate when they are working. That just seems a little low to me. However, my difficulty here is I'm not sure what the problem is with this laptop. The only detail I got on the motherboard was that it was faulty. I'm wondering, is it the situation that the main power rail is fine and the laptop switches on, but maybe it shuts down? So what I'm going to do is I'm going to proceed. I'm going to try and get this laptop powered on and see what happens. But that looks a little low to me. Please put down in the comments if you know any more about this. Again, the model of that is an SI7121DN P-channel MOSFET. What should the value be? As I mentioned earlier, I don't have the little daughter board that plugs into this board that contains the power button. So how do we simulate pressing the power button in that scenario? Well, how we can do it is we can find a super I/O, we can see where the power button signal comes in and simulate the button being pressed. So this is our super I/O right here. It's an MEC1416, and if I look at the data sheet for that, what I can see is that pin 127 is called power_SW_in. So that's where our power button signal comes in. So what I want to do first is measure pin 127 and see if we have a voltage on that. So back to our super I/O here, let's identify pin 127. Well, they actually make it easy for you here because they've got a 1 written here, a 32, a 64, a 96, so this must be 128, and if that's 128 then this one here must be our pin 127, power_switch_in. Now it's so small that I can't even draw it out on the screen with my multimeter to show you how I took this measurement, but just trust me on this one that I measured 2.8 volts here. So what I need to do is I need to temporarily short that to ground in order to simulate the power button being pressed. Now this is tiny. Even on my scan you can see I seem to start to lose resolution. It's that small. So how do I go about trying to carefully jumper that to ground to power this laptop on? In previous videos I've jumpered the power button signal to ground using a small wire or my tweezers. However, the pins are so small on this that I don't think it's safe to use either of those methods. The safest way I found to jumper pin 127 to ground was actually using my multimeter with my thinnest probes. So let me show you how I set that up. First of all, I introduced my multimeter, and this time I've set it to measuring current. Alright, that's the first time I've used that mode on this channel, so this is in current measurement mode. I then connected my black probe to ground, and then with my microscope I very carefully touched off pin 127, and that enabled me to simulate the power switch being pressed. Now unfortunately I can't film both the screen and me trying to hit this with the probe at the same time, but I just want to show you how difficult this actually is and how small it is. So I'm bringing in my probe from my multimeter and I'm touching it off pin 127 to shorten it to ground. Okay, I see an LED coming on here. Okay, so let me just show you what I'm seeing.
So after simply connecting a USB-C power supply and jumping pin 127 of the Super I/O to ground, this laptop is now powering on. As you can see, it's down here as being an Inspiron 5370, which is not the model that it was advertised under. However, I've searched on Google and this motherboard does those two models. I think what probably happened is the person in the store had the board and they Googled to see what model number it fitted and then basically put the advertisement under the first model number that came up. But it's booting, it's getting to the BIOS screen here. I'm not sure what the fault is. Like I said, this is advertised as being faulty, so it may shut down or there may be another secondary fault. I'm going to leave it here on test and see what happens.
That's all I got for this week, guys. I'm making a concerted effort, as you probably saw over the last couple of weeks, to make sure that I get these at around 10 minutes because I think that's sort of a threshold at where people lose interest. But I'll be back with another video this week. I'm almost at 100, which was the 100 videos I sort of made an agreement with myself to do when I started this project. If you have any ideas or where you think I should bring the channel, you're certainly welcome to post them down below, and I'll be thinking about what I'm going to do over the next few weeks. Thanks for watching.